Alright, here we go. So, Unit 5, complex numbers. Starting out with complex numbers, like I said, shorter unit. The shortest unit of the units we have left. Some of our other units are actually really long. Kind of sucks. But this is a short unit. Should be pretty easy, especially the stuff we do today. So, complex numbers. First and foremost, it says write 3 things you know about imaginary numbers. We're just going to talk about it as a class. What do we know? Does anyone know anything about imaginary numbers?
They're not real.
Technically, you're correct, right? Because we have real numbers in math, which comprise rational, irrational, integers, things like that. They are not real, technically, yes. What else did you say, Jared?
They're an I.
We use an I to symbolize an imaginary number. Yes, correct. A lowercase I, not an uppercase, a lowercase. We'll talk about that in a couple minutes. Anything else you know about I's? Maybe what they're used for? No?
Negative.
You're really close. When we do a square root of a negative number, we're going to use these imaginary numbers. Right? And we'll see that again in about 1 minute as well. So, those are imaginary numbers. Like I said, where do they fit in our real number system? They don't. Right? Our real numbers, they comprise rational, irrational, integers, whole numbers, natural numbers. All those numbers fit inside the real number system. Imaginary numbers don't fit in there. Right? So we are going to learn about them though. Why do we have them? Well, x squared equals 36 is the same as what? X equals
6.
Or
Negative 6.
negative 6. Alright, when we get into day 3 and we're solving these, we're going to have both answers. Today we're going to simplify them, and we're just going to deal with the positive answers, okay? So 6 or negative 6. What if we said x squared equals negative 36? What would x equal?
I.
Negative 6
I.
I.
We'll get there, but can you do that in your calculator?
No.
No, that's why we need imaginary numbers. We'll see what this is in approximately 4 minutes. But we don't know how to do that right now. We've never seen that. So right now it's a question mark. In a little bit you'll be able to go back and fix that, but we will find it soon. Okay? So, imaginary numbers were once thought to be impossible. That's why they were named imaginary, right? They're not technically imaginary. They're actually there. They're just not a real number. The imaginary name has stuck with them. And what they've figured out is that when we're trying to take x squared equals negative 1, you take the square root of both sides, x equals the square root of negative 1. You can't do that in your calculator. So you give that name to I. I is equal to the square root of negative 1. More importantly though, if I want to square that, if I want to do I squared, that would be the same as the square root of negative 1 squared, right? We just said I is the square root of negative 1. Well, the square root of negative 1 squared would equal negative 1. This is the really important thing to remember. I squared equals negative 1. This part right here is more important than this part over here. Is this important? Yes.
No. Yes.
This part is way more important though, because there's going to be about 1,000,000 times throughout this unit where I ask you, what is I squared the same as? But we're going to replace I squared with negative 1. I squared equals negative 1. Remember that. It will come up over and over and over and over again throughout this unit. So that is the really important piece from this slide and probably from today. That's probably the most important thing from today. I squared equals negative 1. Remember that. We're going to use it in like 30 seconds.
You're really good on time today.
Yeah.
Man, you're good.
And what?
Like 30 seconds, 4 minutes.
Yeah.
We
I'm
got
just-
about 20 more seconds.
You're going all over the place.
Alright. So if we're going to use it to simplify, if I have the square root of negative 100, before it was believed we can't do it.
10.
Well, what's going to happen is I'm going to change this to the square root of 100 times negative 1. Right? 100 times negative 1 is the same as negative 100. We all agree?
Yeah.
Okay. What is negative 1 the same as?
Alright.
I squared.
I
Oh,
squared.
you guys should.
So the square root of 100 times I squared. Well, I can do that now. What's the square root of 100? 10. What's the square root of I squared?
I.
I.
Wow.
So my answer becomes 10i. Now, once you get really good at this and you start realizing it, do you have to write all this out?
No.
No, absolutely not. Am I going to write it all out for the first few problems?
No.
Yes, just so we can see that process. Alright, yes, Marissa?
Does it matter which side the I is on? Like I-10?
Please say no.
It does. It does, because later we're going to see how we write them in standard form. When we get to problem like 6 it is on these examples. Can I see your paper? No, problem 9. It won't matter. We'll talk a little more about that when we get there. Okay? Alright, the first practice, square root of negative 9. That's the square root of 9 times negative 1. It's the same. What's negative 1 the same as?
I squared.
I squared. I told you I'm going to ask you that a million times this unit. So I get the square root of 9 times I squared. Sweet, I can do that now. The square root of 9 is 3. The square root of I squared is I. 3I. Square root of negative 4 is the same as the square root of 4 times negative 1. Well, negative 1 is the same as
I squared.
I squared. Square root of 4 is 2. Square root of I squared is I. I get 2I. This makes sense so far?
Yeah.
Okay. Negative square root of negative 25. I get negative square root of 25 times negative 1. Negative 1 is the same as I squared. So I get negative square root of 25 is 5. Square root of I squared is I. Negative 5I. Does that make sense?
Yeah.
Perfect.
Okay, try the next 3, please.
Correct.
Try the next 3. Should be pretty easy, similar to the other ones.
Negative. What's 1 squared? What's 1 squared? There you go. Ooh. For this. It's negative 1.
It's fine.
But is this better?
Same.
But is this better?
Same.
He has it too.
Half told you.
Hey, do we need more time for those 3? Or are we good?
We're good.
We're good?
I need time.
Mr. Pomeroy, did you get the first one?
Yeah.
What'd you get?
I got negative 1I.
Negative 1I. Hey, is it okay if I also write negative I?
Yes.
Yeah, either one is fine. Did we all get that answer? Do I need to go through it?
No.
Okay. Hannah, did you get the second one by chance?
Yes. 4I.
4I. Perfect. Did we all get that?
Yeah, it's 4I.
Do I need to go through it?
No, please no.
Move
Are
on.
you sure?
Yeah.
Yes, we're positive.
Okay. Mr. Grant, did you get the 6th one?
Negative 7I.
Negative 7I. Good.
Yeah.
Did we all get that? Do I need to go through it?
No.
Are we sure?
We're positive.
Hey.
Yeah.
You're going ahead.
Okay. Any questions so far? Let's try some harder ones then.
No.
5 times the square root of negative 81.
I got it.
How do you guys think we're going to do that?
5
Multiplication.
root square root or 5 root
What do you keep saying?
5 root 81 times negative 1, and then 5 root 81 times I squared, and then 5 times 9 I squared, or I, and then 45I.
Perfect.
Good job, Jared.
Right? Guys, we're going to leave that 5 alone until we're ready to use it. Right? Do the square root of negative 81. Same as 81 times negative 1. Same as 81 times I squared. Would equal 9I. 5 times 9 would be 45I. Perfect. Same thing for the second one. Negative 6 times negative 36. I'm going to leave negative 6 alone for right now. It becomes the square root of 36 times I squared. Hey guys, is it okay if I jumped over this step?
Yep.
We all okay with that now?
Yes.
Okay. So I take the square root of 36 is 6. Square root of I squared is I. So negative 6 times 6 will be negative 36I. Good. the ninth one. I want you to talk to your desk mates for 20, 30 seconds. Think about how would you do number 9?
This is the correct answer. This is the.
No, you don't do that.
Okay, so. No.
No, I didn't even hear what you said.
Yeah, good job. Poking me.
Oh, so you did.
So I split it, yeah.
Okay.
Ow.
So you
Ow.
like,
Into 4 and 5, and I
we
did
did
2
and you
times
didn't
y, and I did 2 times 2 times square root of 5 times
That's false
imaginary,
out.
which got me 2 times 2 times 5 imaginary.
All right,
I heard that
4
much,
to the base imaginary.
Kylie, Haley, Paige. Did you guys come up with anything?
We found a perfect square in 20.
Perfect. So you did like the simplified radical. What perfect square did you find in 20?
4.
4. So you got the square root of 4 times the square root of 5 times the square root of I squared, I assume? Right? Perfect, right? Break that negative 20 down. We know it becomes 20 and I squared. Right? And then we can break 20 down. Find a perfect square that goes into there. 4 times 5 is the same. Well, that becomes 2 times 2 times square root of 5 times I. Does that make sense? We all see where we got these pieces from.
Yes.
Okay, so I get 4 square roots of 5 times I. That is a perfectly good answer. However, more often than not, I'm going to write it as 4I times the square root of 5. Either one is acceptable. Why do you think I would do the bottom one?
Because it's like.
It looks cleaner.
Well, it does look cleaner, but what might happen in the first one that you don't want to happen? The I goes under the radical. We do not want that. If it looks like your I is under the radical on a test, it will be marked wrong. All right? Yes, sir.
So, I didn't do it that exact way, but I got the same answer. So I put 2, but then I did -4, for the perfect square times root 5.
Okay.
And then I just went straight out to 4i because it's still
So you get 2I out of square root of -4. That's perfectly fine.
okay.
That's kind of doing it the same way, except we split out our I squared beforehand,
Yeah.
which you did, which is perfectly fine.
Okay.
Yeah. So guys, I would write it the second way. That's the way I'm going to write it on the board most often. You can write it that first way, but like Mr. Pomeroy said, we don't want to slide underneath that radical. If it does, it gets marked wrong. Cool?
Alrighty.
All right, moving on. Complex numbers. Any complex number can be written in the standard form A plus BI. Right? We were just talking about what an imaginary number was. Now we're talking about complex numbers. Complex numbers have a real part and an imaginary part. The first part is going to be your real part, plus BI, which is going to be our imaginary part. So a complex number has 2 parts, a real and an imaginary. If I'm looking at a complex number over here, 7 plus 2i, my real part would be 7, my imaginary part would be 2i, right? First part is the real part, second part, the one with the I, is my imaginary part. 1 minus 5i, 1 would be the real part, negative 5i would be the imaginary part. 8i, how do we get a real part out of that?
The 0 that's in front of it.
There's an imaginary 0 there, right? It would be just like 0 plus 8i.
There's a real 0 there.
Yeah, so it's a real number, right? It's a 0 for a real part, and then 8i for the imaginary part. And lastly, if we have fractions, you break it up into 2 fractions. Negative 2/5 would be the real part. 3i over 5 would be the imaginary part. Pretty simple. If we look at these 4 examples. Mr. Casper, what's the real part in that first example? 4 plus 7i.
4.
4, good. Elijah, what's the imaginary part then?
7.
7i, perfect. The second one, negative 2i. Emerson, what's my real part for this second one?
0.
0, right? My real part is 0, it's just like 0 minus 2i. So then Kelsey would be in the imaginary part. The negative 2i, good. 9 minus 10i.
Real part's 9.
Hey Cole, what's the real part?
Oh, 9.
9. Caden, what's my imaginary part?
Oh, it's the 10i.
Just the 10i?
So minus.
The negative 10i. Good. Alright, Cernica. Bottom one, what's the real part?
Well, I'm gonna say, following the rules, I'm gonna say, the real part's negative 10i.
Rest in peace, Jared.
Why isn't it negative 10i?
Jared, you
Because it has an I.
It's got an I, right? That's our imaginary part. So, hey, what's wrong with this bottom one?
Everything's
flipped.
It's flipped. It's not written in the correct form. If we were to write in the correct form, it'd be 42 minus 10i. So my real part would be 42. My imaginary part would be negative 10i. Right? The imaginary part has the I in it. Okay, does that make sense, guys? If it's not written in the correct way, write it in the correct way. Because if you answer questions, we'll see this in a second, you must write them in A plus BI form. The real part must always come first when we answer questions. Alright? So let's do some then. Adding, subtracting, multiplying. Hey guys, look at this. You need to remember that I squared equals negative 1. Really important. So when we're doing this, if we're adding, subtracting, we're just combining like terms. Real with real, imaginary with imaginary. If we are multiplying, we multiply it all out just like normal. Real numbers are way better than imaginary numbers. Anytime you're doing something with imaginary numbers, if you ever get an I squared, you should automatically change it to negative 1. That's why it's so important to remember it. Replace I squared with negative 1 whenever we can. And lastly, guys, like I said before, our answers need to be written in A plus BI form. Your real part must come first. If you put that imaginary part first on a test, it will get marked wrong. Alright? We want it in standard form. So if we look at our first problem, 3 plus 5i plus negative 2 plus 3i, all I'm doing is adding and combining like terms. 3 plus negative 2, my real parts, give me 1. My imaginary parts, 5i plus 3i will give me 8i. That's my answer. It's in standard form, A plus BI.
This is getting difficult.
The second one, 4 times 6 minus 9i. What should I do with that 4?
Multiply.
Distribute.
Distribute. Right? Distribute to the 6, to the negative 9i. 4 times 6 is 24. Minus 4 times negative 9. Minus 36i. Can't do anything else to it. That's my final answer. What about the third one? 6 plus 4i minus 3 plus 6i. We're just combining like terms again, right? Real minus real, imaginary minus imaginary. 6 minus 3 will give me 3. 4i minus 6i will give me negative 2i. My final answer.
Okay.
Oh. The next one's my favorite one of the whole day.
Are you sure?
Wow.
Kind of like the one below it.
How do I do it? 2 minus I all squared. What do you think? Just distribute that squared? Can I do that? Can I just distribute this squared to both these pieces?
Yeah.
No.
Absolutely not. If you do that on tests, I'll throw your test away.
Please don't.
When I square something, guys, I am taking that piece and doing what to it? Multiplying it by itself. Why is it doing that right there? Is this the same as squaring both pieces?
Yes. Correct.
Just squaring the 2, just squaring the negative I. No. What do I have to do to that? It's my favorite 4-letter F word.
This is the foil.
Foil!
Oh, that was my favorite.
Foil! 2 times 2, 2 times negative I. Negative I times 2.
What?
Negative I times negative I. First, outside, inside, last.
It's okay if you don't understand.
2 times 2 is 4. 2 times negative I is negative 2i. Negative I times 2 is negative 2i. Negative I times negative I is positive I squared. Do we all get where those pieces come from?
Yeah.
Sweet. Hey, thanks. Name on it?
Yeah.
Sweet. Alright, so I'm going to combine my like terms.
Yes, we don't believe you.
4 minus 4i. Hey, what should I do with that I squared?
Make it a -1.
Make it a -1. So you do -1 or plus -1. Combine those like terms. 4 minus 1 is 3 minus 4i. Good. Any questions on that, guys?
No.
Alright, should we keep going?
Yeah.
Alright, sweet. We're going to keep running here.
Yes, we're gonna go.
I'm adding, just combining my like terms, real with real, imaginary with imaginary. 3 plus 5 is 8. Negative 2i plus 11i. Positive 9i. That's it. That one was pretty easy. What about the next one? 13i times 3 plus 5i. What do you think I should do with that 13i? Distribute it. 13i times 3. 39i. Plus 13i times 5i. 65i squared. Hey, hold on a second.
Hold
What do I need to do?
Make that a -1.
Change I squared to -1. 39i plus 65 times -1. Well, what's 65 times -1? Negative 65. Good. So just write my answer, 39i minus 65.
No.
Right? Why not?
Because
you have to flip them.
Standard form, right? Real part comes first. Uh-oh, what just happened? So negative 65 plus 39i. Alright, one more. Do we have any questions, by the way?
No.
So
This
far?
is literally what I just said.
First, outside, inside, last.
Foil, first outside, inside, last. 5 times 2 is 10.
You're fucking.
5 times 7i is plus 35i. 3i times 2 is plus 6i. 3i times 7i will give me plus 21i squared. Same thing, combine your like terms. 10 plus 41i plus 21 times -1, right? I squared becomes -1. So I get 10 plus 41i minus 21. Combine your like terms. -11 plus 41i. I think that's it for today, isn't it?
No.
Do we have any questions?
Stop using
No?
pen.
Well, subscribe, swipe up.
Yeah, subscribe.